Good day to all that's here. Hopefully, you are having an amazing day. I want to go ahead and begin to talk about 4C, which is all about solving quadratics with complex solutions. And so, with this particular topic, the focus is on primarily just using one tool. Now, if you were to research how to do this, you will find a couple of different methods to actually solve the quadratics. But in class, due to the time that we have, we're really only focused on one in particular. And so the one way that we really focus on being able to solve quadratics with complex solutions, it was by way of using the quadratic formula. So for those that was in class, you definitely heard me use the song to talk about it. And so I won't repeat it because I think now some of you can hear it in your head. But you will notice it said that this is used for all equations that are written as ax squared plus bx plus c equaling 0. And so the reason why that's important is to let you know that this is only for quadratic equations. This will not work for cubics. It will not work for equations to the fourth power. It is only used for quadratic equations. And the goal of it is to find the solution. So what will x equal? Let's jump right into some examples to make sure we land this plane on today. So we're given the equation of 2x squared minus 9x plus 1 is equal to 0. So one of the main things we want to make sure we do is know what is A, what is B, and what is C. So in this case, A is 2, B is negative 9, and C is 1. So with our quadratic formula being x equals negative B plus or minus the square root, B squared minus 4AC, all of it over 2A, we're just going to start off this whole process by substituting the values in. So x is equal to negative B plus or minus the square root B squared minus 4 times A times C, and all of that is divided by 2 times A. So the first step is simply substituting values in. Now, the next step after this is going to be to do some cleanup. So this is when we start doing some multiplication, we start dealing with some signs, and we start clearing up what this looks like. So we have minus a negative, and so that 9 becomes a positive. I'm actually going to give myself a little more space, so because I'm definitely going to have to write some values below. So minus a negative becomes a positive, plus or minus the square root. Now, negative 9 squared equals 81. This spot should always be a positive number. So if that when you do b to the second, you get a negative, make sure you double check. This number should always be a positive. Now, what follows can be a negative or a positive. In this case, we have negative 4 times 2 times 1. So that is going to multiply together, and that's going to give us negative 8. And all that's going to be divided by 4. Next up, we can do 81 minus 8. That will end up giving us, I believe, 73. And that's correct. So we end up with 9 plus or minus the square root of 73 over 4. Now, because we do not know what the square root of 73 is, we're going to leave our answer in this format. And we're going to stop here. And that's it. We've solved the quadratic equation. Now, it does not have complex solutions because we did not use I at all. But we do have multiple answers here. So that's the end of the story for this quadratic equation problem. So here we go. Let's try the next problem. So the next problem we have is 6x squared minus 3x minus 1 equals 0. We're going to end up using the same quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac, and all of that is over 2a. So once again, identify what is A, what is B, and what is C. And you'll find out it should always be in that order to make sense of it at the end of the day. So from here, we'll have x equal negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So like I said, the first thing we do is just substitute the values in. Now, from here, we go ahead and do some cleanup. So minus a negative turn positive, so that's a 3 in front, plus or minus the square root. Negative 3 to the second gives us 9. So negative 4 times 6 times negative 1, that gives us a positive 24. And all of that is divided by 12. Double check. Yep. Okay. So the next thing we should be able to tackle is that 9 plus 24, which does give us 33. Since we don't know what the square root of 33 is, we stop here. And that's the end of that story. Now, yes, 30 square root of 33, we could use a calculator and find the decimal, but that's not the purpose of this topic or target. The purpose is being able to get to this point where we can see there are clearly a couple of answers at our disposal. Now, there is another side of this coin that we talked about in class, and that was talking about knowing how many and what type of solution can even be produced for us through this scenario. And that was called a discriminant. Now, with the discriminant, what you will note that the way we find it is we do b squared minus 4ac, which if you compare it to the quadratic formula, this is the part that's been under the square root the whole time. So depending on what happens with this spot, it will tell us how many roots we'll have, and more importantly, what kind of roots we're going to have. So if we so happen to have a discriminant, which this is what's referring to, if that number was greater than 0, in other words, if this is a positive number, we're going to have 2 real solutions. So an example that we came across is having 9 plus or minus the square root of 33, all that divided by 4, or whichever number below. Because 33 was a positive, we can say we have 2 real solutions. If this number hits 0 on the nose, then we're going to have 1 real solution. And unfortunately, in this package, I didn't create one that would happen that way. But do know if you follow your quadratic formula and you hit that point where this is exactly 0 on the square root, then you find yourself repeating the number twice when you do a little bit of calculation, but you'll have 1 real root. Now, the one that matters the most, and really kind of what this target is talking about, if that number under the discriminant is a negative, then you have 2 complex roots. That is the same as saying 0 real roots or solutions. So if you have 2 complex roots, that means you have no real roots. You know you have complex root because the letter I is going to be used to make that square root value positive. If you need to pause here and take a note, you may do so. Okay, let me see if I can give an example to give a little bit more context here. Okay, so we have this problem that's 5x squared plus 10x minus 4 is equal to 0. So if we were to just try to determine how many solutions we're going to have and what type, we will still have A, B, and C. We could go through the entire quadratic formula and get a solution and be able to make the call there. But I just want to use what's under the radical to really answer the question, on like how many solutions and what type we're going to have. So in this case, we would have 10 squared minus 4 times 5 times negative 4. That gives us 100. And when you do negative 4 times 5 times negative 4, we are going to get a positive number because we know a negative times a negative is a positive. So we end up with positive 80, which is when you add them together, 180, we get 180. So that would be a case we have two real roots. Okay. Now, let's just say, just to give us a little bit of context here, let's say this was a positive 14. All right. This would still be A, this would still be B, this is still C. In that case, when we talk about doing B squared minus 4AC, we would have 10 squared minus 4 times 5 times 14. So 10 squared still equals 100. But when we do negative 4 times 5 times 14, we end up with negative 280. And that equals negative 180. When that happens, then we know we're going to end up with two complex roots. And that's the difference that I wanted to kind of highlight, just to make sure that we kind of hit the nail on the head there. As far as the two complex root, what would it look like to be there? Because we would technically have this be the square root of negative 180, which we would say is I times the square root of 180. And because we have that I, is another emphasis on why it's a complex solution. So hopefully this video was very helpful. Hopefully it started to answer some of the questions that you had. As always, know that you can definitely reach out, ask questions or what have you. You can always send a message on Teams chat if you have a question at all. I'll do my best to respond at my earliest convenience. Also, you can go ahead and email me as well. And I'm catching up on my email, so I should be able to respond very quickly. Also, you can go check out the instructional material for our course using this link here. And then, as always, you can always visit the Canvas page. It should be updated with the most current information, access and things, and what have you. So at this time, I want to bid you adieu. Have a great day, a successful day, and I will see you soon.